previously it was in the XI soft. So they have hand over the stage to continue this and support.
So, good evening, everybody. Today we are going to cover how we create our own UAV like drone. So it's going to be like targeting. There are a couple of more sessions coming. This is the initial step. How do you get to know partners and what are the things we needed to create a drone? So basically, you can actually get some parts and download the code, then upload and see how it works. But then what will happen is you miss some most important theoretical parts, how it works. When you know how it works, you will know what are the limitations of it and how to overcome those things. So what I am trying to digest to you guys is how to get to know the internal details of how to build drone. So once you know this stuff, you can go with a lot of components available in the market. You can try assembling and try creating your own drone, right? So it's a DIE project, deep user project. This is about me. So I work at Tiqri as my friend Yunus and company called Gayan. Right. So what are the applications of drones? At the moment, these things are actually happening. Like I think you guys know about MS and delivery system, which is already running. So London, they have already gained control over delivery goods. Healthcare system, actually, some of the healthcare systems working with this drone system to emergency delivery of these medical supplies to emergency areas. So that's coming up really fast. And agriculture, why we need agriculture to use drones is they are in surveys. They want to know where these crops are bad, how to give fertilizer over there. So those kind of stuff, agriculture they are using. Not in Sri Lanka, but there are states which actually use drones for these kind of applications. Construction. So construction, as I mentioned, for construction surveys. So the progress of the project can be inspected using drones. That is actually happening at the moment in a lot of United States projects. And in the same field, construction is like 3D mapping. Before actually modeling the building, they actually take visual photography on the air. So that's using at the moment as well. So disaster relief I have mentioned. So they are using these delivery goods and taking aerial photography. So that is So photography is already in Sri Lanka. We can see that today as well. So these are some of the major applications happening. So you can see this image. These are like for agriculture. They are trying to decide how these trees should be manipulated in the field. For these kind of stuff, they are using aerial photography using drones. Alright, the drone data platform. The concept of data platform for drones. There are a couple. There are many applications which uses drone data to come up with analyzing data, right? So you can see some of things are for 3D manipulation. Some of things are for agriculture. Likewise, a lot of applications are there. So you can actually, I have noted down the link dronevictory.com. They have some. I think we can share the presentation, I guess, end of the session, so you can also look at that. Right. So have a look at that site, dronevictory. They have a lot of applications. You can contribute to those projects as well. There are a lot of GitHub projects which you can actually contribute to those projects. That will be really valuable. There are a lot of communities that you want Alright, so now let's come back to basic 101. So these are the very basic features which should be capable in your drone. So auto leveling and safety. So this is the first feature. So when your drone is up and running, it should be in a stable position and it should be hovering in a single location. So that kind of capability should be there in a drone. It should not wander around when you start. You should not go here and there without your control. So it should be start instantly in a single position. That's the ideal scenario. So waypoint navigation. I will show you this image. What is waypoint? So these are like waypoints which you can actually map in a map. Google Map, you can actually take these waypoints and you can ask the drone to follow those waypoints and do automatic deployment and come back. So those are waypoint navigation. That is not a basic one, but that's our target. Waypoint. The drone should take off. You can instantly give the command from the computer. It should take off by itself and do whatever the survey or inspection that should be doing and come back to our location. So that's kind of target we are trying to achieve end of the day. Auto altitude control and altitude hold. So this altitude hold is for there like stationary mode. You want to make your drone in a stationary mode up in air. So for that feature, you should hold the altitude. GPS location should be hold. It should not wander around like 5 feet to whatever. It should be there in a single position and it should hold the altitude. So it should not come down to it should stay. If I set that to 5 feet, it should be stuck still there without going here and there. So return to launch. So this is very crucial. So return to launch is return to home. So for that, why we have this is for safety feature. If they say the remote commands are not received to the copter, it should automatically return. Or let's say the battery drains above 10 volt or something, then it should also come back to its location. Let's say the remote signal went too far, the drone went around 2 kilometers away from you, then it should automatically come back to you. So these are like very crucial settings. For that anyway, you need a GPS receiver set up there, otherwise it won't come back. So automatic takeoff and landing, cover stuff on waypoint navigation. Yeah, driver pan tilt camera. So the camera is not there. This is a very basic one. It can actually support the gimbal. Gimbal is something that you can tilt your camera in x-axis and y-axis like that. So that kind of feature we need. Mobile device control. I'll show you there are some mobile devices that we can control our drone using the mobile devices. That should be really nice cool feature where you can control your drone without this bulky remote control. So these are the features we should try to achieve if you are building a drone. So if you don't have these features, no point building that to be automated. For fun, you can have it up and running, and you need to have the remote control if you are doing it on this waypoint navigation. Waypoint navigation, return to launch, those things are needed if you are to make the drone automated. So there's another term called unmanned vehicles and UAVs. That means it's automatically and come back automatically without any So why I am trying to come back to the drone, which is a quadcopter? Why not a hexacopter or a tricopter or a helicopter? So the reasons are this, right? So if you take a helicopter, you have seen how helicopters flies. It's a bit complex when you have the remote app. If you have a remote flight helicopter, it needs a lot of aviation algorithms to control it. It's not automated anyway. If you try to have a helicopter in this mode, it will consume much battery and it will be very expensive. Then you can't, it won't carry a camera. Let's say GoPro 4 or GoPro 5, you can't use that. Then it will be very bulky one. Then it's going to be very costly. So in this setup, we are trying to reduce the cost factor that you guys can use this for automation. So that's one reason why not going to helicopters. Tricopters, yes, there's a possibility. Then again, tricopters, for trying to fly a tricopter without building a quadcopter, then it's again time consuming than a quadcopter. So quadcopter, if you have the logic up and running, it will be very much stable than tricopter. For tricopter, you have to have a lot of fine tunings. So this can be set up within 1 week or something. You can tune it up and it will be up and running. If you're going to tricopter, it will take much longer time because you need a lot of fine tuning on the hardware devices. So 6 copters, yes, 6. Hexa1 is a very great one that can actually carry a professional camera mount in the drone itself. That's a very nice one, but then again the cost factor for creating a one is costly. So if you go to Hexcopter, it has like up motors and down motors, so it can lift much weight than this one. But for beginners, I think this is the best suited one to go with. So I'm trying to make this one. So you guys can actually try to create one. So with minimum cost. So that's my target. Why we have this one. So responsiveness. So if you compare, if you are trying to picture need. So the ultimate goal is, let's say you want to have a camera which is flying around and trying to video record this session. So that the drone should be in a still position. For helicopter, if you are hovering, it's a crazy idea, right? It will be not possible if you are trying to do that in helicopter. So tricopter, yes, there's a possibility. You can try it out, but that's again bit complex. Yeah. So responsiveness of this one is pretty super. So I'll show some demos. Not here, I have to go out and see. So it's pretty much very fast to maneuver. Quick maneuvers can be done in this one. That's why I have mentioned that one. So nothing have maintenance except if you are having crashes, then you have to like again fine tune your propellers. You have to again balance the propellers again. So those kind of stuff are there, but the maintenance cost is not much. So it's compact. Actually, this frame is called 450 frame. The length is around more than 1 feet total length. So this is called 450 frame. You have 650, 550, 350, 250. So that's the frames we can buy in market. You can try eBay or AliExpress, whatever, for beginning as well. So it's very reliable. Yeah, proof is about 1 month. Alright, so trying to go into this boring part, but I want you guys to digest this one because this is the main part I am trying to give you guys today. Because if you don't have understanding on the theory how it works, you will end up spending much money. If you can create this around 25,000, you will end up spending 65,000 or something more than that because you don't know how it works. If you know how it works, the basic of aviation and quadcopter, then the time and the money will be saved. So I have to spend a lot of time to get this here. I didn't have this one initially. So when it crashes, I know okay this happened because I have not done that part likewise. So today I'm going to give you. So you will be able to create something out of it. Alright, so let's go for this one. I have to want to highlight what is hardware, what is software, and use here as well. Alright, the fun stuff. Can you guys answer for the people having drones or quadcopter? Alright, okay, someone has already done, have. Yeah, I think so I'll try to explain why I have these colors first of all. This was there because I had a crash and I have no black propellers to install, but it should be black. So I have tried these orange colors to be back side of my sorry. So to be back side of my drone quadcopter, and this is my front side. So there's a in aviation there's a thing called when this lift up and you have your remote, right? You have your remote, and I know. So this is how it works. This is forward, this is backward, left, right. So if I want to move front, it will be going like this now. So there's another cool feature in quadcopter. You can actually spin it, right? When you spin it, what will happen is you are going to lost your back side of the drone to something else. Right now, if you spin it just 120, 180 degree, then your front side will be your back side of the drone, right? So then you have to memorize. Okay, now my front is backward. Then I have to, if I want drone to come to me, then I have to pull this to front. So that's a very basic way of a drone work, right? That's the basic of aviation anyway, right? So, but if you have seen your drone, it will not happen like that. It will automatically detect where you are and what is the exact orientation of the copter. So that's because you have a inbuilt compass where it detects. So when this takes up like this, it detects, okay, when this taking into air, the initial orientation was this side is back and this was front. So even when you move, the program will memorize what was your back and what was your front. It will automatically adjust the navigation system with the compass. So that is a good feature we have. Some of the basic drones does not have that. So some people don't like to turn across because sometimes you lose the positions. So if that happens, if you have a low quality compass in your control board, right? So then so how this works is, so as I remember, this is my back. So two motors, I mentioned here. Yeah, two motors spin in one direction clockwise, another works in anti-clockwise. So these two works clockwise and other two works anti-clockwise. So that's how it turns up. The total torque is rotation is 0. End of the day, when we have all the motors with spinning, equal spinning to all the motors, it will be like total 0 torque. Then it will be go up without spinning around. So this is how it works. You have to make sure you have same clockwise propellers. So to take these are two clockwise propellers and these are anti-clockwise propellers, right? So you have to make sure how you actually put these propellers into your so these are if you guys can see the roll is actually the front and back. You want to roll in the sense you are going front and back, and pitch is left and right of the roll. Yeah, is the rotation. So these are the three things you have to memorize when you want to. Yeah.
That logo, yeah.
This one? Yeah, so it means, yeah, so, yeah, is mentioned as a circle. That means it's rotational. Rotation is given vertical axis, that means rotation is rotating, and in pitch is left and right, and roll is actually moving forward. So it complex in diagram that okay that means so if you want to roll in the sense, if you want to move forward, what will happen is the back of the two motors are spinning faster than the front motor. So if you want to move forward, it should be going like this, right? You want to backward, the front motors have more power than the back motors, so it will go like this. So if you want to pitch, these two have more power, they have more power. That's how the aviation works on. Yeah, is something you are if you want to move anti-clockwise, these two have more power than this one. Likewise, it will be moving like the rotation will happen like that. So that is the basic aviation theory. So this is what I have been explained. Net aerodynamic torque is 0. You want to have it without so hovering factor. So hovering is like how you make your drone stationary in air. How you make it stationary is basically by, as is shown, these are motors F4F. M is mass and gravity. Mass and gravity, whatever the equation of mass and gravity is greater than the force of the four motors, it will go up, ascending. And if if mass and gravity is greater than the motors, it will go in down. If equal, it will be stays in the air. So see, ideally it should be staying in the air. If you try to do this in 3 feet, in this one, it will never happen. That's because the wind turbulence created by the drone itself is trying to take this one here and there, because it won't be stable in a room condition of 3 feet from the below. Very hard. You can try. It's very hard with 450. If you have a 250 or 150 very small frame, you can actually do it. Right? Anyway, if you have a GPS device, if you try to have a geo fence, like have a geo fence, like it will be having a circle kind of rotation. When the drone hits the fence, it will be come back and trying to stay in the circle. You have a geo fence. For that one, you need to have the GPS device. It's a very accurate one. You won't have it in 3 feet, right? So most of the DJI stuff actually has it. That's the most famous one I think here, the marker. So anyway, when the hovering mode, when you need to have hovering, you need to have very smooth propellers, balanced, motors balanced, and gravity of the drone is in dead center. Should be able to hold it like this. Something like this should be able to hold. Right, so other frame. Hi. So this is my initial 4-5 years back. I have built this one. This one I wrote it here to show you why I have it. So this was failure one because this is called Raptor frame. Again a 450 frame, but the frame it is spreading than this one. So this has the problem of having the gravity in the dead center. So it's actually moves in this way. So for a lot of forum says, if you are having this one, you have to have the camera mounted here. So it was meant to have the camera because I didn't want to have initially with the camera. I had problem with this one. So you can see this is broken, and this is another GPS locator which is less sensitive than this one. Yeah, so tilting I think I told you guys about tilting. So if you want to build what you call this for pitch. You want to pitch to one side. What happens is two motors have more power than other one. It tries to pitch. All right. Anyone have used PID pit algorithm? So pit, I'll just give you why we need the control theory to calculate this one. So this whole thing is running on control theory. So let's say you want to go in one direction. Let's say you want to have this from down to 3 feet. It will not go like here to here and stays here. It will move here and come back to here and have a wave here and try to stabilize. So it's not a switch that it will be turning on and off to the motors. You won't have direct switches to here like turn this to 400 RPM or whatever. You will have a control. It says you will be trying to give bit by bit, like 2000 RPM, 250, 3000, likewise it goes and try to stabilize the logic. So this is called the control theory. So this control theory is actually also called as feedback theory. It tries to get the actual response from actual position when you give the thrust. For example, let's say you have a car. So you have a car which is climbing. Then you are going at 300 miles per hour, right? Consider you have a car which is going at 300 miles per hour. Then you have a hill which you need to climb up. Then it suddenly go down to 10 miles per hour. But you will want to maintain this 30 miles per hour. So then what happens? You hit the gas, right? When it reaches 30, when it try to come to 20 or something, you let the accelerator go in a slow motion manner. You just not take off your foot from the pedal, right? You gradually move your feet away from the accelerator, or you have a stable fuel coming to the engine, right? So that's how the feedback mechanism works. So that is called proportional part. So what that means, you are trying to adjust your vehicle to always have 30 miles per hour. So that even we have a certain hill or a whatever, you try to make sure you have 30 miles. So what now is you have gradually putting your feet, putting your gas throttle like slow motion manner. So you can see you observe the effect and you try to change it. This is the cycle what we are trying to achieve on this one. It's a very famous theory. Alright, so this is a very basic way of trying to present what is a peak. So peak is called proportional integral derivative parameters. So just talk to about the proportional part. So proportional part talk about percent. So what you actually need, what you're trying to achieve, is given by the proportional part P. We call this as Kp. I show the equation. It's called Kp. So that is the most considerable part in the equation. It tries to maintain your speed in our example, 30 miles per hour always. So you can see you are applying proportional control to the car speed. Exact number. Yeah. Deviation is called the future. So you read it's about the amount of speed drop. So how is it say you have a the hill comes up, suddenly goes to 10 miles per hour. That means you have to capture how speed the drop is coming. That is actually the deviation parameter. Tries to capture amount of speed drop, right? That's deviation. And integral. The third parameter is the path. So this actually sums up all the errors. Error in the sense, read up. error from the target speed and providing feedback to proportional. So it's like how many times I have to correct myself. How many times I have to correct myself to get it to 30 miles per hour. So it actually sums the count of actions in the occurrence of the speed drops. So you have the amount of speed drops, count of speed drops, and the achievement, the error rate. So if the proportion part, you can say the error. So proportion part, you can say 30 miles per hour, and you have your drop is 10 miles per hour. So 20 miles per hour is your error. You have to correct 20 miles per hour to get to 30 miles per hour. That's the correction part which you have to do. We okay with this one? Not clear, I can. Fine. So I give the slide. I will give the basic understanding and the basic way of trying to give the what is the P. So yeah. So PK is the P, proportional part. Is the integral, and D is the derivative. So sum of this one is the one we are giving to the motors. So this is the value we are giving to the motors. We have these error parameters to get to our target. So for example, in this one, you need to achieve target altitude of 100 and you are at 50. The P proportion is 49. So this is your P, right? So this is how it happens. Take the sensors, get the altitude, calculate the correction, apply correction. This is cycle goes on, right? So if you are to write your quadcopter program by yourself, this is only thing you need. End of the day, you can write your Arduino code with this one, KT, KIN, KD. So this is the, let's say you are, for our example, 30 miles per hour car. So these are 30. You can see how we try to achieve. So end of the correction, it should go like this, but the correction happens like this. We have to have these three parameters to do this. There are other. I have skipped the equation without these parts. Without these parts, there are other steps which you can try out. Without I and D, how it works likewise. Actually, in a fine tuning, you have to fine tune these three parameters in the copter. Right? You have to fine tune these three parameters. So, per axis state control. So, this is the output we are giving. Desired output error. So, you have the sensor reading, desired reading from your remote control or whatever. And the calculation will give you what is the needed value. So to get the rated PID, you have to fine tune your device. It's end of the day, it will be like a table kind of a thing, which will have for this speed, this is the output. For this state, this is the output. Like kind of a thing will be created for your program end of the day when you have the fine tuning done. So this fine tuning is very crucial. That will be like take a lot of time than creating everything. Alright. So we know the theory now. We know the theory. Now, what are we going to do? So, the hardware. So, open source hardware. What people are working on Arduino at the moment? So, I think this board, you can see this board. I showed you in the picture as well. This is Arduino board actually. It is built-in, pre-built compass is there, some calibration stuff is there, and directly you can couple the remote control, everything is there. So you have a pre-built board. So I am using this because if I am to make this one, the cost of power is more. Like I can do the same thing. Then what happens is the other peripherals around it will consume more power than the build from this one. So I cannot make this. If I want, I have to bring this board by myself. So this is more productive than creating your one, but it won't stop you from creating your one. You can try it out with the Arduino board itself, right? So we have thing called like open source. You already know the open hard drive talks about this kind of Arduino stuff where there are forums and communities where you can get support, and they have open standard of how this design comes up. So we have a concept called open design as well. So these some of the interfaces are open design. They have adapted this open design so other vendors can follow this design. So for example, this they has a standard. This base has standards. We can ask this your they have this standard. Likewise, everything is standard here. So there are a lot of manufacturers you can try to make that if that standard is there. Alright. So here we are going to I'm going to show you why we have selected why I have selected this board. So there are many type control boards available in the market. I want to show you what are the boards available for us. Don't have anything. Continue. this you can see this guy is actually trying to show how this PID works for one axis. So if the input is the original target, the target here is to have the drone stable in your y-axis. So then the whole motor should be in same hovering mode. So then try to correct itself. Supposed to correct itself. So by giving this motor much power and this motor much power to this one, try to autocorrect itself. So this is how it actually tries to correct itself. So these are some of the famous codes which we have in the market. So the KK, the Hoping KK2 code, this is a very famous one. This doesn't have GPS capabilities, so auto landing and autonomous navigation is not there in this one. But you have other features like auto labeling and everything is very smooth in this one. You can this board is less than 2,000 rupees, as I know. So I have yeah, I have one here. So this is one of the board I have tried. You can actually see the PID values in the screen. You can try to adjust your PID values from the screen button itself. So bit easy for beginners. I would like people try out this one for beginners, so you can get to know how it actually works. So that's one thing. Yeah. The people we are using DJI. This is the board. NASA 32, NASA 64. These are the boards, internal boards you are having in your DJIs. So NASA 64 is the one you are having in what we call Spark and latest one. Those are the boards having. So this board can be purchased around. Yeah. The earlier one, there are a couple of versions for this one. Earlier days it's around 50 bucks or something. $50. That means around 8% or something. So the problem in this one is the source is closed. You can actually burn your firmware. There are a couple of firmwares available, which you can actually download to this one. But you can modify that. It will be like you have firmwares in the store. You can actually copy it and push it to your drone. So, but this is a very stable if you compare to this what I have, right? It's more stable, this is more stable. But it has less features if you compare, you can see the pins. You cannot have much outside controls. You can't have your obstacles over system with this one because it's closed, source is closed. You can't actually do much here. But again, it's very stable. Hoovering is best in this one. So trying to have best hoovering without anything else, go for this one. Yeah. So OpenCC3 3D is another famous one. This is also around 3,000 rupees. This has less features, it's very stable as well. You don't have much features like the Arduino one what I'm having, but it's very stable. It has auto PID correction itself, so it's a bit easy. If you are a beginner, you won't learn much. But if you are trying to have quadcopter by yourself, it is be stable at the beginning. You can use this. One of the best ones I have seen. So multi-view is something like the first one I have seen is the first one I have seen the TK board is another version from this. Then as well, it has more features than the initial one. This one, the same manufacturer you create this one. It has more features than that one. The problem with this one is and CC3D is the forums are and the documentation is a bit less. They have the Git projects as well. You can contribute to, you can compile the source by yourself and do wonderful stuff, but it's very limited compared to our audio copter. So what I'm using is the audio copter one. Should be I have not used this one. Because I have seen, I have used. So this is the one I am using. So this supports not only this thing copters. You can have it for any cars or whatever vehicles. You can program this. So it's a very you can have more users with this one. If you don't want your copter, then you can use it something else. It has more configurations, templates available which you can actually download and use it. This is one of the, but this board is around, when I bought it, this board is around 8,000 or something, 2 to 3 years back. Yeah. So last version, again the DJI one is closed anyway. You have the same kind of internal circuit like that, but more features are there. I think this one has the GPS as well. Yeah, they have GPS, so you can do autonomous routes with this one. CC3D is more stable than KK. The KK one is bit hard to like control it. If you go for CC3D, it's easier to control this one. The price wise, KK board is around 1,500 or less than that. CC3D is much stable than that. That's about the board selection. So regardless of these boards I have mentioned, you can go for Arduino Uno. You can use Arduino Uno and have your firmware from these things and run your chip and use it. The problem is that you have to have much hardware knowledge on the voltage dividers and all those stuff, but it's still you can do it. But the customization is a bit tricky when you don't know the aviation parts. If you know the aviation parts, how it works, and if you have experience with the propeller balancing and how the motors, amperage and all those stuff, then it's much easier to program in an Arduino basic board. If you don't know the basic aviation parts, better not start with that one. Once you have knowledge gained from other board, then you can start going with that one. Otherwise, what will happen is you will end up burning motors, burning boards, likewise. But just get capability of doing that anyway. I'm going to show you. So that this page was, I think, sometime back 2 years or something, kind of old one. So I have noticed this board came very recent. This board. I think the reviews are very good for this one. They have like own custom software. So after you can customize. Here you can customize it as well like Arduino code. So and it seems like it's 32-bit one is bit cheap compared to Protocopter one. So I haven't tried this one, but I think it's a very nice one. As once I read the comments and everything, it's very good. Yeah, it's cheap, 32-bit microcontroller. So Arduino is not 32-bit anyway. Yeah, it doesn't have flash memory, so PID is not safe anyway. But I have seen it as a different. Are you guys okay with the speed, or if I go change, go speed up or slow down? Right at the back. Any comments? Okay, interesting. Okay, interesting. If you have questions, just please raise your hand or ask me. That will be okay.
So the basic algorithm in those both are the same.
Yeah.
Control plane?
The control is nothing has changed. It's very old. It's developed in 1980s or something. It's a very old algorithm. It has been using for all the stuff, even maybe the daily cars, washing machines, everything is using this ideology. Once you know how it works, then you try to tune it the way it wants to tune it. For me, what happened, I did not know the control theory in the beginning. Then I end up burning motors, giving up this whole thing because I don't know how it works. Then I had to go to the forums and ask them. Then the first good thing was someone has already mentioned, go to this one, then you will learn how it works. Then it's a bit easy to program more. At least try to configure it. So, we talked about I'll share the slides and just go through these sites and compare. There's one this thing I think it have a table kind of thing where you can actually compare the features. That's kind of a nice one, but it's old but still useful to have a look. Alright, so now we have our board selection. My board selection here. If you are trying to have, remember to buy lot of propellers because that tend to break daily basis. In the time of buy bulk. So why we have gone for monocopter? So Arduino copter, so they are shortening them and monocopter. So this is UK design was done by UK, now it's manufacturing in China. So sir, they have well documented the site. It's really nice. Can actually, it's an open source one. You can actually contribute to this site. You can have your documents up. You can fork the repository and you can actually give the change request to them. We have documents you can upload to them. They will sometimes that is reviewed. They will take it in. It's a highly active, large community base. If you have questions, most of the questions I may answer. If you have anything, they will answer in very soon. The GitHub link you can. So let's try to have the initial setup here. The next session is to actually have use the source. From the source you can build. This is Arduino code anyway. You can actually compile it to 32-bit any control. So this active project. Ground control station. Mission plan. So this is kind of a neat one where you have your ground control station. You can actually control the part using wireless telemetry kit. If you don't want to use your remote control, you can use your desktop control station to control it. So this is your telemetry kit. This is called telemetry kit. This is the this your receiver of your desktop, and you have a transmitter in your quadcopter as well. So it has its own slot connecting this board, right? Most of the stuff anyway do. Lot of open source designs have this connector. You can buy this 4 meters or something. Less than 3,000. It has 1 kilometer range in it. If you are to use this in your phone, you have this small device you can actually plug in a USB and the phone thing. You can actually control it from your like this, something like that. So it's always good to have this else, but you have to connect your device to the USB cable. The same standard we have. You can connect this to your board and start configuring or reading the logs and whatever. So ground station, this is the normal way I connect. So these are the parameters read from the memory of the device. So I think DJ has kind of ground station itself, right? So it's now connected. So these beeps are talking about the ESC initialization spaces. You can see GPS is not fixed, so this means internally the working very well. So it's better if we have now open area is I can actually disable the GPS and actually start, but when the return to home is not getting enabled. So I don't like to turn that signal, disable GPS. You can see everything is that is okay. It's okay. Only thing is GPS. So disarm because of that. Because that's the only thing holding that. Otherwise, it will be. Yeah. So all the open source projects, they have this arming feature. So this disarm in the sense when when you apply current, the power it will not start. That's because it has a safety feature. Like these propellers are very dangerous. You try to hold it up, so you get hurt. That I have done many times. So they have a safety feature like you start at the disarm state. You have to move your mouse to left. So you have a way of doing that. It will be initialized. Not getting it. So you can see the receiver has a video as well. If you turn the remote on, if that is pair, you can see this pair. That means you have some use. You can connect. The problem is we are not getting the GPS lock. That's the only thing that we are having. So, but you can see these variables actually changing your needs. But if you arm it only, you can get this nice things happening. So yeah, so I was trying to give you the heads up on this mission plan. So in order of the mission plan is the most critical part, where you have many what you call variables, like all the parameters are available here. You can see the logs as well in this one. Okay. So you can actually see the logs and all those variables actually available to you. So as I describe you what is this. This is like if you are a beginner, or if you try to have the firmware download to your device in a faster way, this is the easiest way. So you can select the frame in here. My case is a quadcopter. There are hexacopters and there are two configurations quadcopters anyway. Right? So yeah, couple of so this is the famous one, the X1. So this I haven't used. This is the most these two are the most gravity center is most accurate in these two modes. I haven't used this one, so this one I use. This is a hexacopter. Yeah. So we have so the sensors. I have talked about sensors. So we have a couple of sensors in internal to this one. You have a accelerometer and a compass, right? So accelerometer actually detects the speed and compass the direction. So compass calculation is there. I have switched off. That was not there. So we have a battery monitor device. You can come to see it. I have a small battery monitoring device. Why we need this battery monitoring device is that, let's say the correction is happening really fast, then the voltage to the main board drops. When that drop happens, there's a noise comes to the analog inputs of the Arduino board. If there are noise coming to the Arduino board, the whole calculations of the sensors are screwed. So you will not get this fan running in a stable mode if those noises are coming from the analog pins. In Arduino, I think you have come across these scenarios. You have analog pins. These analog pins are crazy stuff. If those are, let's say in your home, you have 5 volt, it will work. When you try to set up in somewhere else, even that is 5 volt, but the sensors readers are totally separate. Almost something else. So that for that you have to have a reference voltage to be accurate. So the reference voltage actually taken supply as well. So you have to have a very clean, stable supply. Otherwise, Arduino will not work. I have seen a lot of people trying to create hovering mode. Hovering mode is not achievable if you don't have a very stable power source. So this, what this try to do is, one thing is it has its own stabilizer. It's not a regulator. I'm not talking about regulator. Regulator anyway try to control the power source to be 5 volt. The problem is these ESCs, the motor controllers, eat a lot of amperes. So when the amperes are taken by these things, the source current is have a drop. That drop is affected for the analog pins. So what we have to do is we have to isolate the current to ESCs and the main board. So this is very helpful there. So in here, you can say the versions. Yeah, these are the versions in APM. Photocopter mode, they have a couple of versions. You can select the version. I am having APM 2.5. So you can say the amp for the battery. So this has a battery monitoring capability as well. It will automatically land. If the battery voltage is less than to a certain level, it will automatically land. You can configure this via the ampere rate of the battery and some other parameters that you set. Sorry, I don't have mouse here. I'm struggling with the mouse. this is actually the your remote calculation of the your remote receiver. So it needs the maximum pitch value, roll values, maximum yai values, and maximum roll values. So you have the roll, pitch, and yai, the throttle, and these are the radio. There are some other functions controlled by this node, so you can calibrate those things as well. So this is very crucial when you before you having a new device. Once you have this device, it will be very easy. So if you are doing these things manually, then you have to calibrate these things anyway before you actually start the drone. So there are ways. If you can see the source, it's in the below side I have mentioned. You can see the source how it's done. It uses the EEPROM to save the data. Once you have it, we use the EEPROM to load the data for the. These are some modes. You have active default mode, RTA return to home mode, sport, active stable is the one we are normally having. Stable is the most the hovering mode. So in hovering mode, you have this setting. Active hold, this is the next setting. So the one thing I have noticed is when you use a lot of GPS data, the battery life drains to 50% faster than without the GPS activity. So if you are running stable mode, I can use this for 30 minutes of time. If I start this active hold mode, it will be lasting more than 15 minutes. So that's kind of a drawback with GPS data. There are more devices like this has 6 6L1, that the other one is 4L. So the receiver's type is there, depends on the type and accuracy. More accuracy, more voltage is used, more juice is used to the GPS device. Then you are going to lose the flight time anyway, right? So these are the some of the stuff you need to know. So you have noted the simple mode. The simple mode means that it memorizes the orientation when this is started up. So if I start like this, it will be memorized. Okay, the back of the quadcopter is this. So it will be so even if I this one, if I rotate this one, it will be memorized. So I don't mind rotating this one up when I have this simple mode enabled, right? So that's one of the cool feature. It's much easier to navigate when I have that mode enabled. So notice some of the flight modes you don't have that one. So you can from my this one you can actually control this mode. I might be able to show you on this connector. That's are the basic settings that we normally do. After that, this will be automatically downloaded your device. So let's go back to the slides. Am I going too fast? Okay. Speed is okay.
So the values in the device, is it like creating new firmware or is it like just configuring?
No, it actually burns the new firmware and the value. Or if you can set it to only burn the parameters only. So if you won't have to every time burn the firmware and the parameters. If you are going to that visa, it will always burn the new firmware into it with the parameters. So without burning, you can actually configure it.
So then the remote corrections are actually in the firmware, not the remote itself.
Yeah, correction is actually in this one, not in the here. Yeah. You can actually see. Yeah, see these are parameters. Yeah, so this configuration they have like there are have a basic, standard, and advanced. When you have advanced one, you have more variables that you can configure in this one. So you can see the sensitivities are actually there only, but they are so these are the sites where you can actually find the stuff. So auditing this takes much time, land anyway, but quality of the is okay. I have tried bandwidth and ALI fixes, those things, the things comes much faster. That I have just why I have mentioned. eBay takes longer than Infinix anyway. So this assembly part. So this is the best assembly diagram I can find in the net. This is a hexagon anyway, but we only have to do for code 1. So you can see the ATM board is there. You have GPS device connectivity, and this is the receiver. So this is your receiver. This is your GPS device. So notice GPS device is mounted higher than the board and these ESCs. So the magnetic fluctuation of these ESCs are disturbance to this GPS device. That's why it's up in there compared to other stuff. This also have a compass, but I am not using this one. This one is more accurate than that one, so I am changing this one because it's getting screwed up in here when these ESCs are started. So you can see these are the ESC connectivities. I have only 4 ESC connectivities. So in here it has mentioned 6. You only have to have 4. You can actually it's mentioned as 1, 2, 3, 4, 5. Yeah. My numbers are there anyway. So you can directly calculate those ESCs. And you don't have ESC at the moment. Here is the RF module. This is the RF module. You have direct connectivity to that one. And yeah, and the battery. That's the only thing I have. And the battery. Yeah, you can notice this is the wire coming from the battery monitor to control the landing, auto landing features. So this is the basic diagram. So again, I have tried to show you configurations. These are the ESC connectivity this side, and telemetry. This is the wireless telemetry. These are optional things. You can actually configure these things to your automation part. Let's say you want to have object concentration, then you can use these things to have your object concentration. And you have your remote send receiver connectors. Notice you have a I2C interface as well. You can do any other readings from the device for send communication here that one as well. So notice there's a forward arrow pointer in this one. That because that has its own compass. So if you are using that one, you have to have your forward and you have your motors the same way. And if you are using GPS compass, GPS device compass, then it has a device the setting anyway, the arrow. So you have to have your motors wired in that angle anyway. Yeah. So this is the internal of the board anyway. You have FPGA port, USB. Okay, I have the optional pins. So this is one of the versions of our new. So these are again a configuration which I have in. So the outputs, 4 motors output wire the motors clockwise to, if you, this is the forward manner, so you have two clockwise motors and two anti-clockwise motors. So they have to be very careful when you are having that one. Alright. Yet another wiring diagram. Yes, the battery mounting component. Anyone know why we have 3 wires to the motors? It's a 3-phase AC motor. So these ESCs are actually create the 3-phase electricity from DC. So what's the harm when we have 3-phase motors in a system? So it creates a lot of noise. It creates more power. It has more power, but the electromagnetic disturbance is very high, and the noise injected to the main line is very high. So the more POEs is more more faulty ESCs will reduce the injection to the main line, main supply line. So most of the injection are coming to the ESCs. Don't try to buy cheap ESCs. Higher the quality, higher the performance stability of the board. Alright, so again, frame selection. So I showed you why we go this one. So initially you can try out this one. This is because it has its own PCB beneath. You can see the ESCs are actually soldered to the board. So it with PC when it's having this soldering there, right? Otherwise it's a bit hard when you try to have these wires going here and there and try to shorten up. So initially try this one. After that you don't need this one. You can actually create from a very small piece of platform anyway. It's much lighter than this one. Yeah, the feature is inbuilt power distribution board. It's much nicer and has smart value if you compare to creating your own one. So lesser the weight, lesser the battery drain, right? Alright, so the ESCs 25 output amp. So you better go for 30 amp output because 25 will get needed if you are having 45 frame and 110 motors. 1010 motors, 1100 motors. So better to have 1400 motors, then the heat is very less. These motors, when the motors are heated up, they tend to fail faster. So 1400 motors are a bit expensive, but it's actually good. If you notice, I have 2000 motors in this and 2400 moters. That's because I didn't have money to buy another two. You can try. You can actually, if I can demo it, you can see the heat level of these motors. These 1400 motors tend to heat less compared to this one. So these I try to give this graph because these beeps are a bit important. So when you start it up, you will pick the beeps in a synchronous manner. The synchronous manner means these motors are in sync. If you hear these beeps one after another or in between, then you have a synchronous between the ESCs. Don't arm it after that. So these beeps are very important. If these beeps are not synchronized, that means you are in trouble. I have very bad experience when I started this one without synchronizing the ESC. So most of the stuff you can do the synchronization from the remote device anyway. Yeah, I might be able to show it from there. So we are doing dipoles because these are much lighter. So you don't need the Arduino board to try to start these motors. You can have the ESC by the 3-phase motor, and you have the receiver. You can directly connect the receiver and start. You can try it out this motor without propellers anymore. Alright, again the PCB layout of the wiring. So it's nicer when you have the inbuilt layout. There will be much these wires are going. Then when you have wires for these three-phase motors, it also affects the noise factor in the system. So this is much nicer as a ground. So this is the EC diagram. Here, 3-axis accelerometer, 3-axis gyroscope. It has its own processor, 35-volt. So this is inbuilt in this one. So I just want to highlight, if you are trying out with Arduino Uno, you only need this one. So you have to have accelerometers of 3-axis. These are sensor input POP, right? what is the direction and what is the speed? Values are there. Also going to contribute to the different factor. So if you have Arduino, you can actually connect this one and try it out the other source. So this is less than 1,000 rupees as I know. Yeah, so brushless outrunners. So why we have brushless and why it's outrun? Three-phase motor again. You need brushless because these things are rotating at very high speeds and they need more power. So brushless is one of the best ways to do it. Outrunner is that you can see the body of the motor is turned. Actually, the magnet is the outrunner. So 920 is if you only need the stable flight, you don't need to have acro mode, or you don't need to perform stunts. This is more than enough. But the control, the responsive is bit less, but the battery drain is less, and yeah. So these motors, you can buy go for the DJI motors, then you will have a very low battery drain. Then again the price is bit high. They are going to DJI ones. Yeah, propellers. So one of the major factors. Sorry, forgot to mention about the motors. Normally, these motors, when you get this one from the manufacturer, they normally what you call balanced. This is your propeller board. This is balanced. It's like wheel balancing. It's already balanced. You don't have to do anything. But if you get a crash, you end up moving the axle, and most probably you will not have a stable flight after that anymore, which I am having at this moment. So it's very hard when you have these errors in your spindle. So anyway, these DJI motors spindles are much stronger than these Chinese ones I have used. But again, price is a matter. So the best way is to see the vibration is having one motor assembling one arm and try to spin it up. The propeller should be mounted in the other way around, so it will be go down, not up. Then if the arm is jerking here and there, you can feel the vibration. Then you have propeller. So when you have 4 motors, the vibration is much more vibration. You have properly this guide of thing. So you have to have very less vibration. The vibration comes from these motors and these propellers. Do they have break?
No, just continue.
So follow up now.
What are the terms?
So think I remember these are 10-inch ones. Then you have 8-inch ones. The control is much higher there, but the power you need to bring it up is much than 8. So for 8 one, you have to give more power to bring it up or down. But if you have 10, it's much lighter. The motors are spinning less to bring this up. So you need more battery power, better to go for 10-inch ones. That's more stable than having 8 ones. So beware that they have anti-clockwise and clockwise propellers. So you can see the size. Yeah, you can see these propellers are size. You have to make sure you have this correct side and you have this link talk about propeller balancing. This is a very crucial one. Even any propellers came from manufacturer, you got from patch. Even you have to make sure these things are balanced. Propeller balancing is a crucial step in your platform. Without the balancing, don't think of stable flight. So the propeller balancing, there are two things. You have to balance the propeller edges and the spindle. This spindle has balancing and also sometimes they bend to one side only. So you have to balance the axle of it or the hub and the entire propeller as well. So they have nice figure. So this actually have 1 kilometer range. This is 6-channel one, and quite okay with the power consumption as well. You need like 8 batteries. I have rechargeable and we have rechargeable ones anyway, so you can use it over and over again. So with six channels. So what is the 6 channels? So we take this section. This is our road. So road is all up and down. So this is one channel, and this one pitch left and right is one channel, and here and total is one, and here is one. Now we have 4 channels in here, and this is my 5th channel, and this is my 6th channel, right? So you can assign any of the channels to any of the features. It is up to you. If you need to have a auto tuning peak, so in this NPM board you have auto tuning peak feature. So the implement is automatically try to have this rated PID table itself. For that one you have to make this in on air. You have to make this on air, and you have to have a very decent clear area that you can go here and there without disturbance. So, but you can't achieve that with this one. You have to have some modification with this one to achieve that. You need a 7th channel, or you can disable the 6th channel and assign 6th channel feature to 7th channel to make it as a auto tuning control. Likewise, you have to have a tweak to make it as a 7th channel, make the 7th channel feature to do the auto tuning of PID. So either you can go for a 8-channel one, then the cost factor is much higher. So this you can buy this for less than 6,000 as I think I talked about the GPS compass module. So this is one I think I got it okay. Just check. Accuracy is good. Then again, Indo is not there anyway. It's anyway. So the battery is one of the major part in the quadcopter. You can see the battery size of this one. This is 5200 mAh battery I have here. You can see how this export is actually expanded to to its limit now. Next it will be going out. So where these things actually go out. I got my room burned because of one of these things. We have 3 cells. You can see these are cells. Normally the IPOs come as 4.2 batteries. If you have 3, then it's 11 something. So 3 batteries are series together to make level 10, level voltage. So make sure these are quality ones. Right? This was around 10,000 anyway. It's after 1 year time we try to fade away. So try to have a good one. So the thing I have seen is the lighter the battery, the cost is higher. So this is less than 200 something. So you can have the same 5200 milliamps battery with 100 grams as well, but the cost will be double again. So this is one of the good brands. Tiqri is one of the good brands about the batteries. This is a 2.1, just showcase to you. For this one you need a 11.1 battery, and be sure you have very good charger. This one actually charges the cells separately. So this one is actually one of the best one. You can actually measure this is also okay. It actually have the cells indicator as well. It's okay, but this tends to short the batteries. But this one actually more safe. If you go to this one, this is around 3,000 rupees as well. So you can actually charge 3 cells, 2 cells, 6 cells likewise. There are many configurations for this one. So the battery, the battery voltage should not go higher than 4.2. So those things are achieving goal, but this is more accurate. This has a temperature temperature line as well, so you can actually cut the temperature line to this one, like have it touch the battery temperature sensor, then it actually cut off if that heats up. I learned it in the hard way. Better to these things actually get short, cells get shorter, very common. So don't leave them unattended. You charge it and go away from home and come back tomorrow. Your home won't be there. Because if you don't short these things up. If you short it within a split second, nothing will be there. Right? It has you see this ESCs. They say 25 discharge rate. So these are the rate how fast the current can be discharged. Normally, normal batteries we are having, even in a car batteries, we have 1C, 2C. That means 1C is compared to this one, 20C. You have 25C, 20C like that. This is actually C. I can show some stuff. Yeah, this is 35C. See how bad it has got. So 35C is 35 times faster than a normal battery. That means you don't have bottleneck. If you have a water in a bottle, if you are trying to turn it around and try to get the water, it will be getting as drops. It's like for this one, it's a valve. Like we be very careful with these batteries. Alright, I talked about this one. Next you have one of these one. Once you have this one, the site is very stable. And then you do that. Okay. So pretty good to have this one. Otherwise your wire will be hanging and you won't leave the rocks. So you won't leave anything. So this I want to show you this graph. So the mission planner has a log reader. So you can see these are the vibration levels for the axis. Right? So this talks about the vibration levels. These things comes because of your propellers and your motors or your wires are tightly holding your board. And make sure these wires are really loose so the board can vibrate. It's like for engine, with your engine mount. It's supposed to shake and tight. It should not shake according to your whatever the vibration. So these the vibration are expected. So if you have this one, you are nowhere having a decent stable mode. So these are the called vibration dampers. I have 4 attached to this one, so it can move freely. Make sure you have these things. So you try to start moving. Alright. So first part, so the easiest way to get this up and running in Autocopter is the mission planner. Or you have the second option, get the source from Arduino GitHub, compile it in your Arduino and run it. That's a nice site I have mentioned here for the Arduino version. Exactly Arduino anyway, you can do it from the mission plan. The problem with this one is calibrating is only can be done from the 7th channel auto tuning of PID. You cannot feed the values to the table. What you can do is hard code the values from your calculator, whatever the remote values or the axis things, you have to calibrate them. You have to feed in the code. But if you are the mission planner, you can actually give them instantly via the wireless communication. So I tend to use that one because when you want to start a new software, it's not easy. And the mission planner links. Right. So this is the end goal. You can in the mission planner, you can select create your waypoints. You can start the mission and it will automatically go into these locations and come back to the original location. So is everything available in mission planner as well. This is on. Yeah, you have a drone planner in your mobile. So this is a drone planner. There is a mobile version of the mission planner. You can actually try this one now. It has some bugs anyway. You can. There's a fork from a couple of people. They have fixed a couple of bugs, but that is not merged to main branch. That's the problem. Yeah. Yeah. So you can see some apps gimbal. So I have not set up the gimbal. If you want to have the gimbal, then you have to have the stands as well. The stands are actually another 200 grams weight. So I don't want to have this thing because it gives a tight time. Yeah, that's about the presentation. Any questions so far?
So normally are there like forwarders rotating like at a nominal speed or like to increase flight time can you reduce the rotation speed of all?
No, you can't. It's actually so. I think you understand this. Can do it. So this is the diagram. So the forces of the 4 motors must be higher if you want to climb than the mass of the copter and the gravity. Mass of the gravity into mass of the copter into gravity should be less than the 4 motor forces. So if that is equal to this, so it tends to anyway your gravity is just you can reduce the motor speed by having more lengthier propellers. That's one thing. That's what I'm trying to do here. You have 8-inch propellers, which actually reduce the battery power, but the response is bit high. That's why they are using 8-inch propellers. Here I am trying to have more battery power, so that's why they have training for us. So also make sure the propeller lockers, these have sides. So these sides, if you have a anti-prop propeller, the what you call the block should be clockwise, right? Otherwise, what will happen is in there the block will be no longer available, and you will end up propeller flying away from the propeller. Believe me, I had these scenarios happen. It's quite funny. So this ESC is tend to burn. Normally you have low quality ones, they tend to burn. So make sure you have good qualities, and those are not shorter. So these are sleeves. Make sure when you are connecting these things, you have sleeves. These are the sleeves. These are the sleeves. Of course, a plastic cover kind of thing. When you burn it up, it will be straight, and it will be fitting. It's not sellotape. It's heat resistant anyway. You don't use sellotape or insulation tape. Use see here the motors are connected to the ACs using these things. So, and this is you need this one anyway. This is your propeller balance. You definitely need this one. So, how you do is these are not costly ones. These are very very cheap product. Even for any drone, you need this propeller balancing. So better use this. So it's like this. So it should be like this. So image is good like this. It should not go like this. That's the thing. If it tend to lean to one side, that means this side is heavier than that side. So what you do is you have to sand this one a bit, and don't sand too much. Bit by bit you can see you get to this level. And it's not correct anyway. Even your propeller staff, two sides are balanced, your hub is not balanced. Then still you may have to balance the hub only. You can try. So better have that one, or you can
How much it would cost to buy like instead of hardware?
Sorry?
How much it would roughly cost to buy instead of hardware?
And
How much it would cost to buy full set of hardware?
full setup
Yeah.
for this one, right?
Yeah. With the backup stuff also.
to buy a couple of more propellers. When you control, you can enable this. So notice that Amazon has Amazon.com. The Chinese, they send good stuff to Amazon.com. So if you are trying to buy something for drones, try to get from Amazon.com. They can send cheap good things to America. So I normally try to get from all my friends in USA because they China also send good stuff to them. So they are much reliable than what we get from China. And if you're going to Amazon, it's cheaper. We have seen this.
So, when you have this automated flight planner, is it enough to just rely on control system, or do you need some additional learning behavior when you have bad weather, for example? So to keep the stability, can you just rely on the control?
Yeah, it should be able to rely on. So the wind is anyway a matter. If you have bad windy condition, anyway it tries to correct itself. Because that's the theory. If you want a stable mode, if the mode is stable, if you want to stay in 3 feet or 10 feet, it will try to stay. But when you have more windy situation, it try to correct much faster, right? Your KD is higher. When you have KD higher values, the drain is higher because the motor is getting more values, right? A lot of data goes here and there. But it's achievable. Then when the battery drains, it will automatically come to your launch location.
How does it control the altitude?
Yeah, it has a barometer.
Barometer.
Yeah, I forgot to mention that. You can configure it. You can actually tweak the maximum amount. Anyway, this has the barometer one. This one has not very accurate anyway. So it has a very higher error rate. So you have to tweak it anyway to work with your boost. Let's say if you want to this in 10 feet, it will be in there in 100 feet. So the barometer is only there on this one.
Very built into the board, right?
Yeah, it's built into the board. It's not very reliable, but you can tweak it. You can configure it. You can have to board it's different. But you have to tune it like you can add the error value. For 10 it is 100. Then you know what the error for the barometer. Anyway, it won't work less than 10 meters or something because it's the sensitivity of that is not. But the NASA, that's one of the best boards you can see in 1 feet level. The barometer is good. There's a videos you can see very nice one in NASA.
I'm gonna go ahead and show you how.
So this is a correct
We have a front balance of the
to the balance.
the hot.
Notice
Actually, I think you can find
so
this
I
one
can't
on
move 100% down.
fairly inexpensive. Basically, you have these two rubber little grommets. So what we would do is take, drag. Just a second.
So no matter what position
Like
you put,
this,
you
let
should
go of it.
stay as it is. So here you can see it's tend to move to the gravity.
So what we would do is take, and you can either sand off back in. I like to use the sanding method. Drop. No, not drop it at all. So you've accomplished that.
So
Now
this
is
means your
down.
two sides of the propellers are balanced,
Down this way.
right?
See how it's coming this way a little bit? That's the hub here, the center part, right?
That means your hub. The hub is
What it is, this
turning
side's a little heavier than this
one
side.
side unbalanced.
And so, see, from this way when it drops, it's showing us that we need to take a little material off of here, or the other side. But what's dropping this way?
So I can't do that in this.
No, it's not dropping that way. That's a perfectly balanced gravity again.
So what you can do is you have to have these flips anyway. You can buy this one and have the two cups, two glasses, and put it there, and you can actually balance it. You don't need this one anymore. So it must nice to have it. So make sure your hubs are
If you take the time to do this, you're gonna end up saving the copter, it's gonna, motor's gonna last long.
You can see the GPS is somehow it got activated. I think the injection is coming up. So it's reading from his computer. So somehow I got the GPS application. It's getting clear from the GPS now. So anyway, this is not a in Indo you won't work much in GPS. I have seen some devices which work in less GPS. So you know that at home button which works perfect. You have this terminal where you can actually send command and see the logs and everything. By the way, pretty cool to see the data logs and everything. You can see There are a couple of commands. If you go to site, you can see the commands you can see. That's about it. I want to show you something here. You can change the parameters. Any more questions?
You said that we have to be careful when charging batteries, right?
The batteries and the I have forgot to mention not only batteries. These things are propeller guards. So you can actually use these propeller guards. It will become you have the propeller guard. It will be come to like this extent. So then if you not get damaged when you hit the something, it will just again bounce back in the propeller guards. The bad thing is when you have propeller guards, they add 100 more grams to the system. So again, you like performance of safety.
So how does the commercial drones handle this battery problem?
Anyway, it's not more than 30 minutes.
Safe, right?
If you have when you have more features, more data transferring the controller, end up reducing the battery life.
No,
Anyway, you have
safety. I mean,
safety. Yes, they have the propeller guards in it.
I mean, the battery safety.
Battery safety anyway, they have their own compartment. It won't be going like this. To have the DJ one, they have separate compartment. Even that explode or burn, it will be internal only. So in here we don't have it. You can see DJ, you can have a nice cover on this side. It's very protective cover. If you try to make it up, you can see have a lot of aluminum covers and all those stuff. Battery. But propeller guards, people tend to remove them due to weight.
So if we have this kind of drone, what is the major change we have to do in-house navigation?
Automation.
No, I'm asking if you have this kind of drone, this is navigation by the GPS points, no?
Yeah.
So if we want to navigate in-house,
In-house, then
what is the
you
major
have to
change
have,
we have to do?
you have to have these range detectors, supersonic range detectors. You can connect your range detectors to these edges. So the obstacles will be detected. So in your path, if you can see this range detectors, you will detect the object. And there's a project in there from the range detectors. It actually projects the into vicinity, like it maps. You get a map when it's up and running. You can actually get the map. The computer can see the actual map there. So kind of cool. But they have used Raspberry Pi for the project. On top of this, they have feed the pins to Raspberry Pi, and the Raspberry Pi communicate to Wi-Fi and get the changes and get the map.
So when it comes to indoor navigation, how do you automate it? I mean, without GPS.
That's one thing. You have ultrasonic sensors.
Is it a cloud
sensors.
map or
Sorry?
is it a cloud map or something like 3D mapping?
No,
Point?
from the ultrasonic, they can detect the distance, right? So, let's say if you have this sonic sensor here, they will detect this notice because they have a range, right? They scan the range and you can get the data, and you can actually detect this object from the distance from this one. So that's one way they can map the device. map the location. It's like how the web price is ultrasonic, right? The same way you can generate the mapping surrounding via the ultrasonic.
You can do the, the waypoints and all.
Waypoints is difficult.
Yeah, I can add it to his answer. So this regular LBS system, like it is not easy as we are using a GPS navigator. If you are using indoor, so you have to program your own LBS system. It can be using ultrasonic or Wi-Fi based, anything. But you have to code it. There are no specific plug and play devices to you can get like GPS. GPS is the easiest way.
Can't we use BLE technology?
You can use. You can iBeacon or you can have PLA devices stuff in the location and navigate to it. Just achieve.
What means making a mesh?
So, what's the language you used for mostly C?
This is Arduino, right?
It's Arduino.
C.
C.
It's
It's
basically
like
C.
C, Java mix. If you're done in C#, you're there.
But if you are going to be like your own LBS system, but this Arduino board I think not enough for processing. So that's why he said that one guy is using the Raspberry Pi. The Raspberry has more efficiency in performing this trades.
The Arduino Mega can be used.
Yeah, Mega.
Mega can be used. So you don't need to feed the data to your computer. You can do in-house processing in that chip as well. Mega.
If there is a relation between mode and TV value and the translate of the mode.
It's like the average RPM is around 1000 or something to get it to 3 feet for 400 frame, 450 frame. So it's achievable by 9900 modes. The higher the motor value, the power it has is higher. The RPM value can go higher. So the heat distribution of the motor is less. Then the battery drain for heating the device is not there. So that's a genius getting from having a higher motor. Again, some people argue if you have a higher motor, then the coils, the turn coils take much current. Yes, but heat dissipation is something you have to take into consideration when you are in this kind. And one thing, I saw one camera project people are doing. They have set up like 4 cameras into this here, and they try to project the indoor vicinity. So that is already there because some of the if you have rain detection system in your normal camera, they have used that technology to detect the boundary walls and everything. So some kind of technology is also there. So that cameras already have that feature. They have hijacked that firmware and they have modified it, and they send the data to the Arduino board. So the internal cameras do the calculation by itself, nothing to do with the Arduino board. They just send you can't go this way because you are hitting this board within this distance.
So what is gathering the image from this?
Yes, that camera is doing it. And these cameras run on 12 volt and consume less than 500 milliamp hours. Pretty good. The only thing is when you have 4 cameras, the rate is bit higher.
What is your personal recommendation control board for drone? So
It depends on what you want. If you want to have more acrobat kind of features, NASA is the best one. NASA is one of the best performance devices, right? Then you can't code anything there. You can't, the pins are not like this, it's not open anymore. They have limited capabilities, you can see the analog pins. You can send the details to it, but the output is, you have tried out and see. There's not human anywhere. Of course, that one of the best tools I have seen in performance wise. And yeah, that device very good. The barometer is very good. Internal compass, you don't need this one because they come with the GPS device as bundle because these are pre-calibrated for you. In here you have to calibrate this one. The rest I have calibrated. If you are going for more, like you said, the indoor navigation kind of stuff, this is more cool because you have a lot of pins. Here you can have the ultrasonic sensors directly connected and working in the itself. It's much. Arduino is one. This is one of the most community is most strong in this one. This one I have seen in some conference and a lot of folks are there. So these are going there. One thing I was unable to show is the demonstration. And that is so we can use actually.
Is there any more question?
With all these components, how do you keep the weight down with the quadrocopter?
Yeah. One thing is this frame. As a beginner, try with this one. If you want one that is done, second step is don't use these things. You have seen antenna bus, this very thin aluminum bus. You can use this aluminum bus to build the structure using this aluminum bus, right? And revert it, or pivot two bars and assemble the motors to the bus, right? You can actually just assemble it. You can actually connect to the antenna bus. This is the assembler to mount the motors. This was a aluminum based. You can use that. Then it's very lightweight. And get the battery, 5000 milliamp battery, less than 1500 grams, 150 grams. So lesser the battery weight, much flight time. And other thing is get the motors around 1400. It can DJ motors. Those are pretty good. These come to the efficiency part. Go over those motors. Have the propellers around 10 inch. And don't go carbon fiber. These are less weight on the carbon fiber. Then if those are hit by you, with those things you get cut off from your fingers or anything. These things tend to break. Carbon fiber won't break, it will break you. That's it. And one thing is the fine tuning. Once you get this PID corrected, then you will have more flight time. And get these GPS devices have 6 receivers internally. So 4, 6, 8, 12 light weights goes. Higher the receivers, higher the accuracy. But again, when the accuracy is high, the drain of the battery is higher. So you have to train yourself with what is the if you want indoor and if you want to GPS, then the flight time is double anyway. You are not using the GPS. And if you have seen this DJI Spark mover, they have the camera inbuilt. The camera one you can actually detect the motions as well. You don't have to have the remote. You can from the motions you can actually control the okay. It's not big thing. You can if the image processing is there in your camera, you can see this one as well. So it's not on the board, it's on the camera. That's how technology is.
In this, two motors are 1400 kVA and other two motors are 1000 kVA. Is some effect?
Yeah, it's just it.
So how do you control that part?
It's actually why I can't control. One thing is my flight time is getting because anyway I am not using, normally I don't use actor mode. The mode time is stable, so I don't use much of RPM. I try to use the copter in a stable mode. So the RPM is around 2000 or something. Then anyway these things can take that. One thing is flight time is almost around 30 minutes. So better to have these lights. Otherwise you won't detect your backside. So normally I have this one. So AI is not used most of the time. So I used to have these LED bars for the night lighting. won't see the lights in it. To have this light ready to, like.
Yeah, are these motors and other stuff waterproof?
No. These motors are not waterproof. You have IP65 motors. Then these IP65 motors are, those are not heavy. Thing is, bit expensive. The cores are not there. You can see these motors. These are also despite this reduce the heat. So these things are mounted separately. You want, but the yeah, and the board is we have to get from the mode the mode anyway. You have IP65 casing anyway. You can mount that. It's not a big thing. Only thing the motors are a bit expensive. Then ESCs are anyway board anyway. Those things come to scale. ESCs are much okay for some heat conditions.
Are there any legal constraints for these in Sri Lankan countries?
Yeah, I think in Colombo they have a legal constraint. You have to get certificate.
Is there any maximum altitude or something like that?
With the new rules, I think if it is a small, with the weight, they have defined those rules. If it is 200 grams less, you can fly it within your premises. If it is more than that, having 4 cameras and cameras, then you have to have your own license. You have to register your own police stations, and you have to get the license. Then only you get that.
And
I will try to share that link. There's a link with explaining that too.
because this photography was anyway uses these drones with their buildings and all those elements. They have to get this license.
How about the custom regulations and when you buy it online?
Only thing is the remote. Other things you can get it cross because those things are not taken as this getting down the remote is you have to get a approval from PRC if that is more than 800 meters. So this is 1 kilometer long, you have to get the going the current.
Any more questions? So we'd like to thank Jan for coming here in this session, and we are expected to do a lot more. So our plan is to, since we did 4 sessions here, like doing IoT, analyzing everything. Today onwards, what we are trying to do is mix those things with the drones and analyzing everything in Azure. So I hope that the coming up sessions will be very interactive and interesting to cover with you. Okay, thank you again for the session. And one more here, I'm informing because you all know this for the Azure Discord, JetBrains are sponsoring with their license keys. Like with this voucher, you can go to online their site and you can purchase any product 100% free. Okay, this okay. I have 3 vouchers for this May meetup, and 2 is going to be for 2 questions and 1 for 1 referral. Okay, so you can ask 2 questions from the audience. And I didn't do that. So last time I did a small mistake. I didn't get the winner's detail. But this time there are 3 coupons. I need your details. And if the last time winners, if it's here, please make sure you have purchased this one. Because I got a mail from JetBrains that from 5 licenses there are 2 remaining which is not redeemed yet. If you guys not redeeming it, it will affect my next meetups. So once you have this voucher, within 1 week time, you just go to the site, purchase what you want.
Can anyone explain what is integral in our context?
Regarding the past,
Integral. Yeah, so in past years, you explain a bit more.
in the past data and improve the quality of
It's like error correction.
Yeah. Any provision?
Yeah.
He's doing it. That's why it is my hand. I just wanted to say that raise your hand first. Since everybody answered to that, shall we go for another one? Everybody. Because it is unfair if it is they gave a last try, but okay. So just raise your hand and the team will wonder that who raised the button first.
You have to auto-tune helicopter. What is the channel you use? Seven. You have to complete the 7 channel.
6 channels.
Signal
Yeah,
is
7
one
channels.
channel.
You can control. Okay, because I need to send everything what I'm doing here for the difference. Okay, next question. So how to name it? There's a small link I have printed there. You can follow the URL and get it.
So there's a problem in the copter. Yeah, when you increase the yard, it suddenly lost altitude. So what is the remedy for this one?
And compensation?
No. You try to increase that, is the answer.
Is the angle
Yeah, it is not correct.
Only increase and increase the
It's any, yeah. Yeah,
You understand?
the question is, the quadcopter is in a stable mode. It's working perfectly now. But when it sudden movement, it don't give the desired one. Try to give, it lost the altitude.
Arguing of mode.
Yeah, how to resolve that?
Like, I mean, you need to get the IRP mode.
Yeah.
Okay, so there might be a chance picking this number. If the winners will be there, if it is, we will go for a second round. Okay. Tiqri, the .NET organizer, he is the one who introduced this guy in the Discord. I would like him to just take the lucky winner. Yes. So it should be Nimanti one student. Nimanti, okay? You are in. I need this back. Please feel it and you will the other mover. That is the most valuable asset we can do. Okay guys, hopefully we are done for the day. I hope you gain something new today. Okay, we hope you have a lot of situations. You can use this kick to do your own projects because there are a lot of technology in this country. Because if you guys are taking this 2 minutes, if you guys experience this past weather scenario and whatever situation we have to face, if you have proper technology in there, everything in place, so think how we can avoid all those scenarios. Okay. Actually, we team get together to develop one system. We are doing so. We invite all your team to get together with us to make a better Sri Lankan technology. Okay, thank you, and there is a smart week for you. Thank you very much for coming today, and thank you again, Sam, and thank you.
The moment I uploaded sample video to the job sometime back, it's like when I'm going to remove it, because we review. It makes like.
Okay, that's what I'm